You agreed to join your friend on a road trip from Phoenix to Oakland. You depart from Phoenix at 6 a.m. with the odometer set at 0. Oakland is 752 miles from Phoenix. At 8:30, the odometer reads 177.5 miles. At 12:15 p.m., it reads 443.75 miles. Write an algebraic model that shows the different distance traveled over time. So they're looking for us to use this model. So let's write down the information that we know. We know you leave at 6 a.m. Keep that in mind. I'm going to highlight that and put a star because I know that will play a factor in answering the questions below. But when you start, we have two values here. When you start, we're going to call this time 0. It's our starting time. And how many miles have you gone? None. The odometer is set to 0. This is the number of miles you've traveled on the trip, and here's the time. We haven't gone any. We're not going to put a 6 down. We're going to translate this into t equals 0. Now, the next time we look down, we're at 8:30. So the difference between 6 and 8 is 2, and then we have 30 additional minutes. How many minutes in an hour? That would be 60. And you have traveled 177.5 miles. Lastly, to go from 6 to 12, 6, 7, 8, 9, 10, 11, 12. So 6 hours, and we have 15 additional minutes. There are 60 minutes in an hour. Oops, sorry, I didn't mean to put that in. And then how many miles have you traveled on this trip? 443.75. In order to come up with the slope, that's our first step, you choose any two of these. It doesn't matter which to choose. I'm going to choose the first two. So 0, 0. And now I'm going to plug this into my calculator to come up with a decimal amount. 2 plus 30 divided by 60 gives us 2.5. Oops, sorry, you didn't get to see any of that. I changed this into a decimal. And you could do the same thing if you chose to use these two. You could go 6 plus 15 divided by 60 to get 6.25. Okay, so I've converted this into a decimal. This is 2.5, and this is already in decimal form. This is my first point, my second point, and first point and second point. So x1, y sub 1, x sub 2, y sub 2. Now the slope, you do need to remember this formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Rise over run. And I always suggest to prevent making a mistake is to use those parentheses. Y sub 2, 177.5. Y sub 1, 0. X sub 2, 2.5. X sub 1, 0. Now if you want to use a calculator at this point, that's okay. Just make sure to use parentheses. So you do need to show the algebra. I'm showing that. And you need to show the algebra. I'm showing it. So I've used parentheses on the numerator, parentheses on the denominator. So what does this simplify to? It simplifies to 71. Remember, m is like a rate at how fast we're going here. So y equals mx, so mx plus b. Now some of you are going to realize that what is our initial? Our initial is 0, and you're just going to put a 0 in this place. Others may not recognize that, so you choose any one of the ordered pairs, plugging 0 in for x, 0 in for y, and solving for b. 0 for y, 0 for x, and solving for b. Now, you could have used 2.5 and 177.5. You're still going to end up with the same b amount. So 0 equals, anything times 0 is 0. And we don't have to subtract 0. We get b equals 0. What do? I have a b and I have an m. Here's my equation. Y equals 71x plus 0. Is it essential you put a 0 there? No, it's not essential. But this will allow us to see how many miles have you and your friend traveled since leaving Phoenix at 6 a.m. So at any given point in time, we can see how many miles have you driven. Let's get started here by first going through each one and trying to see what are we doing here. How far? Remember, x is like your time and y is your distance. So how far? I want to know y value. When I'm given a t value, okay, I got to think here. How far is it from 6 to 10? 6 to 7, 7 to 8, 8 to 9, 9 to 10. You can make dash marks, you can count on your fingers, or you can simply subtract. 10 minus 6 is 4. So I have a t value of 4. We'll come back to that. How far? Again, we're wanting to know distance. That's a y value. And I'm giving a time of 11:15. So from 6 a.m. to 11 is going to be 5 hours, so a t value of 5. But we have additional minutes. Additional minutes. So there's 15 additional minutes, and there's 60 minutes in an hour. How far? So from 6 to 2, 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1, 1 to 2. So I've gone 8 hours, and then I can see that from 0, 0 to 30, I've gone 30 additional minutes. Okay, what time? So whenever we do time, I'm going to zoom out here so you can see this. I'll move this back up. Whenever we do time, like right now, I'm recording this, and it is 12:32, 12:32. So we're going to have hours here and minutes. To do that, we have so many hours and so many minutes after 6 a.m., the initial time. That's going to help me to answer this question. And then what was your average speed? So average speed, that just means your rate. Your average speed is 71 miles per hour. Average speed is just your rate. It's your slope. Okay, let's get started. Let's take this, do second plus 712. Again, second plus 712, we're going to go to y equals, and we're going to type in the equation, 71x. And again, you can put plus 0, but putting plus 0 is not necessary. Now, how long are you going to be on the road? We really don't know at this point. So let's come up here. We know we can't have 0 hours, and I don't know how long it's going to take to get to Oakland. I know that's a really long ways. I'm going to put in just a large amount here. I'm going to put in a full day. I know it's not going to take a full day, and I can adjust that later. And then I need to do zoom fit. So zoom fit. So this will be able to show me the distance I've traveled at any point in time. Okay, so I could say after 1 hour, how have I gone? After 5 hours, and so on. So how far have you gone? After 4 hours. Second trace, and we're going to round to the nearest tenth. So 284 miles. Okay, next up, again, now we don't have an exact. We're going from 6 o'clock to 11:15. So second trace value, 5 plus anything in parentheses. Sorry, any fraction is going to go in parentheses. And I'm going to round here. You know what? That's a pretty nice number here. 372.75 miles. Going on to part D, second trace. And I'm going to do 8 plus 30 divided by 60. 603.5 miles. Notice that the trip to Oakland from Phoenix, we're getting close, so I know it's over 8 hours. What time will you arrive in Oakland? So I know the amount of miles it takes to get there. And Y represents the number of miles. So I can type in 752, and let's see where they intersect. Okay, this is when you're going to land in Oakland. Second trace, intersect, let's figure it out. I want to write down this exact number. 10.591549. Don't round this. Don't round this. And you should try to be neater than I am so you can read your handwriting. So it'll take 10 hours. Now I'm going to translate this into minutes. So it's like 59% of an hour, a little over half of an hour. 0.591549 times how many minutes in an hour? That would be 60. And I'm going to round this to the nearest minute, 35. How does it help me answer this? Well, if we start at 6 o'clock, so we're going after 6 a.m., 10 hours after 60, I'm just going to literally count. So here we go. I'm going to make this up. I'm going to go, not make this up, but I'm going to make my little check marks. So I'm going to do 10. 6 plus an hour, so 6 to 7, 7 to 8, 8 to 9, 9 to 10, 10 to 11, 11 to 12, 12 to 1, to 2, to 3, to 4. I've done 10 hours. So I know it's 4 o'clock p.m. I've started in the morning, early in the morning at 4 p.m. And now there's 35 additional minutes. 00 plus 35 is 35. We can assume at 4:35 p.m. you will arrive in Oakland if you continue at this same rate throughout the trip.